Andy Darnell.
Okay. I was looking at the quiz. I'm really familiar with the concepts, but they're asking a lot about the density curve, which I did not remember. Like, I watched the videos, but I don't remember a lot about it. So the density curve always lies on or above the horizontal axis. Because there's one that says, oh, under certain circumstances, a normal distribution can drop below the x-axis. That would.
Oh, I thought it wasn't allowed to drop below.
No, it's not. I don't think so.
Yeah, because I wrote that down. The density curve always lies on or above the horizontal axis.
Yeah, exactly. Yeah. So for question number 3, it's 1 because that's what it should be. It said on the slides.
The total area under a normal distribution must equal 1. Yeah.
Yeah.
Well, it's under the curve, which is the normal distribution, I guess.
Yeah. And then a normal distribution curve is symmetric. I feel like, yeah, it should be.
Yeah, it should always be symmetric, that bell. Under certain circumstances oh no, false. It cannot drop below the x-axis. The symmetric, true.
Use the following image to answer the next 2 questions. Which of the following elements of the figure represents the z-score? So it's not the area. Oh,
I think it's A and C because 1, isn't that 1 the z-score?
No, the z-score is the shaded in part, if I'm not wrong. So
it's A. Well,
yeah. Because isn't the z-score the
z-score is the standard deviation.
So it would be, because on the applet, it's like the bottom numbers are the z-score. So would that not be? Oh, no, it's C. It's C.
Oh, because it's pointing to the 1. Okay.
Yeah.
We were right initially. We just couldn't figure out which one it was. Okay.
Yeah. Okay. Which of the following elements of the figure represents the probability that the z-score will be greater than 1?
B. Isn't it B?
Yeah.
Mm-hmm.
I think so.
I think so too.
Okay. I love this rule. This is my favorite. It was my favorite thing to learn in Math 108.
I'm glad you like it.
I know.
Not too bad.
The teacher was like writing in, she had like a page on it on the main page, and she's like, a lot of people have been having issues with this, and I was like, I love this. Like,
yeah.
Okay. Okay. So 1 standard deviation of the mean. So
what percentage of the data from the bell shape is within 1 standard deviation? 68.
Yes.
So it's 0.68. Oh wait, no. Yeah. Just write as 68.
Right, your answer is a percentage. Oh yeah. 68. Yeah, because that's the first one, and then the 95, and then the 99.7. Suppose that the z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between 1 and -1?
If it's between, you shade the middle. I know that one.
Okay. Give your answer as a decimal.
Is it area? So 0.6827?
Hold on. I'm going to do this really quick. So it would be 0.31. It would be, okay, so what I got is 0.3173. Because I put the numbers in, because it's asking you the z-scores between these 2 numbers. And so you just fill those in, and the area is what you get from that. So I don't know if they want us to round.
See, but so I put in 1 and I put in -1, and then I shaded the middle because it's between. And I got.
Oh, yeah.
Yeah, because that's how I got the 0.6827.
Yeah, you're right.
And then isn't it 0.683 because you round up?
Yeah. 0.683. Yeah, it even shows you like the rounding in the question. All right. And so this is and this is the same just with 2.
Yeah. Does it say between?
Yeah.
Yeah, so it's the middle stays shaded.
So it's 0.9545, which is 0.955.
Yes, agreed. 0.955.
Okay. I really hope you do better on this one. I feel like I really get this, but I really hope it's not one of those things where I understand and it's, you know what I mean?
Yeah, or like you're like, I understand this. No, I don't.
Yeah. Okay, so I did the other one, and it's also between, which means that
the middle part is shaded.
Yeah, so it's 0.997.
Okay. Be careful about your answers. What did you observe?
Oh, these ones. Actually, it does. Look. Yeah, it does. Look it, because the last 3 answers, it's 0.68, which is 68%. And then the next one is 0.95, which is 95%. And then the next one is 0.997, which is 99.7. So the values match the 68, 95, 99.7 rule.
Yes. The probabilities double as you move? No.
Okay.
Oh, from Z to 2? No, it still doesn't double. And as the Z-score increases, the area between Z and minus Z decreases. No. So it's the first one.
Yeah. Okay. Question 13. So long. Why wasn't last week's questions this easy?
I know, but then you're going to get to these ones and you're going to be like, dang.
I know. That's exactly how I feel already. I'm like, oh, just kidding. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. And then it has the numbers. The population mean requirement for adults is 6.65 grams. And the population standard deviation is 0.07. So, what proportion? What are they asking for?
What proportion of the population have a protein requirement that's less than 60?
Isn't this what's it called? Z-score. Aren't we figuring out the Z-score? Wouldn't that make sense because they gave us the standard deviation and then the mean?
Yeah.
Okay. So
variable minus mean divided by standard deviation, and that equals a Z-score.
Yeah. So it's divided by
population mean is 0.65, and then the population standard deviation is 7. But what is the value?
So then it's 0.60 minus 0.65, and then you get your answer, and then you divide that by 0.07, and that should be your answer.
How'd you get the value?
Okay.
Oh, it tells you right there. It tells you right there.
Yeah. So like right there. Those are the values. So you just subtract. Yeah.
Yeah. So what did you get?
So I got negative, and it's telling you to accurate to 3 decimal places. So there are definitely more numbers than this, but it would be 0.714, and even rounding it would stay 4. So it's negative 0.714.
And then it says what proportion of the population have a protein requirement less than 60?
Oh, they're asking for less than. Okay.
So wouldn't it just be 0.71? 71%?
Well, yeah, it says give your answer as a decimal accurate to 3 decimal places. So it's 714 because those are 3 after.
So it's not a negative.
Oh, wait. I don't know. Because I know how to, I mean, obviously we're doing the z-score. Okay. So, so it's less than. Wouldn't it be
Yeah,
that?
that would make sense because you're to the left,
Yeah.
which is negative.
Yeah, and then just a thought, not really sure, but for the next one, would we add perchance?
Mhm.
Because it's asking for more. I don't know.
Proportion have a protein requirement. Wouldn't it be the positive if it was a bell?
Oh, the positive of what we just got. Is that what you're saying?
So 13 was just 0.714.
Yeah, I think so. I think you're right.
Let's see. So then 13 is negative 0.714, and then 14 is positive.
Yeah, because it's more.
That's just the opposite side.
Yes.
I think so.
I think so.
That sounds, yeah.
Okay. What proportion of the population have a protein requirement that is less than 0.7?
So then you just do 0.7 minus
0.65, and then you divide that by 0.07. And you'd get the same, actually, which is interesting. I wonder if, I want to try something really quick. 70 minus 6, point. And then I wonder if you could divide that, because it's asking for less than. And I wonder if, no, it's the same. It's just negative or positive. It doesn't really matter, which is really weird. Because the values are different, because you have a 6 in one, and then you have a 7 in the others.
So it may still be inside of that bell, right?
It could be. But the only question I have is why, well, I mean, it's positive for a reason. But, no, it makes a lot, because it's just the wording that really confuses me with this one. Because, like, I know how to do it. It's just I'm not sure if what we're doing is actually completing the requirement. You know what I mean? So.
We can always try it, and if it doesn't work,
Oh, yeah, you're meeting with the tutor tomorrow morning, right? Okay, cool. Yeah, let me know how that goes, because I'll be in class, so I can't make it to the meeting, but.
Well, I asked her if she could do later because that works better for me, and I don't have to wake up like 3 hours earlier.
Yeah.
But I mean, we'll see.
Okay. Let's hope. Okay, number 16, find the probability that a randomly selected person will have a protein requirement that is between 6 and 7. 0.6 and 0.7. Hint, remember that to find the area between two values, you shade to the left of the z-score. You calculate. Sure your answer is positive.
Oh, so you put the z-score in.
Yeah, I think.
Right?
I think you're supposed to fill it in on the applet.
Yeah, that's what I'm saying. So like 0.714 and then negative 0.714.
Oh, no, I think because the z-score, they're already giving you the z-scores. And so you just put in, because it's between 0.60 and 0.70. So I think you would write 0.60 and then 0.70. Oh, no, wait. This makes no sense.
Well, if you put in the 0.714, because you found the z-score for those, and it's the same, if you shade to the left, the area is 0.2376.
Oh, only, wait, are you talking about the middle or?
To the left.
Oh, like only to the left.
But it does say have a protein requirement that is between. So wouldn't you shade to the middle?
I think you're supposed to shade to the left and also have the middle one, because in the video, I think that's what he does. I was watching this earlier. Because he, let's see.
It just says find the z-score and put in the positive and negative values to find the area. And then shade between.
Yeah, so less. Oh, okay. So they have questions on, yeah, you just find the normal z-score for those ones.
So isn't that one 0.7624? So it'd be 0.762.
Yeah.
0.762. And then to find the 35th percentile, you click on the areas with normal distribution curves so that the only area shaded in blue is on the left side of the left line.
Yeah.
So just the left side.
And then you do 0.35, right?
Type in percentile number in decimal form in the area box.
Mm-hmm.
And then that will use the z-score under the left red line and put into the formula x minus u plus z times o to find the value of x, which is the percentile you're looking for. Does that make sense?
So are you, it's the opposite of the z-score, right? Because you already have the other.
This one is steps to finding a value when given the area or percentile, which is less than 50th percentile.
Oh, okay. So what do we do? I'm sorry, I was so lost.
So you type in the percentile number in decimal form in the area box. So you type in like 0.35.
Yeah.
Put the z-score under the left red line and put in the formula x equals u. So u
is the mean.
Is the mean. And then that's, so it's u. What's the mean?
The mean would be.
Sorry, I'm like also trying to eat dinner. I never have time for anything.
Oh, it's okay. I feel like the Because this is asking about z-score. This one is not asking about z-score. Oh, near the end of the video is when you find the other ones. So the mean?
Yeah, it just says use the z-score under the left red line. So the negative 0.38. Put into the formula x equals u plus z times o to find the value of x, which is the percentile you're looking for.
Interesting. Because I'm looking at the video and it gives you the mean. So I don't. Okay. Wait, unless the original question has it. Okay. A randomly selected person. Calculate and then subtract. Shade to the hint. Remember that to find the area between two values, shade to the left of each z-score you calculate, then subtract the smaller area from the larger area. I don't think we did that for those ones. We should look back on those later. But
we just have to know the mean number because we have z. We have
yeah.
What we don't have is the mean. Do we need to find the mean? Do you even have enough information to find the mean?
No. I don't think so, but I think that we do. We just don't know how to look for it. Or maybe, I just don't know. It's confusing me. But it's like, the mean is the most. Because normally on a 68, 95 to 99.7, the mean is what's in the middle. And so
if we click in the middle is 0.
Yeah, exactly. So
Oh, but if you shade the middle, it changes the area.
yeah. Because a full, would it be 1? Could we try 1? Let's try that. So it's, because I have this formula over here. So it should be, nope, this is the wrong thing. It's this one. So yeah, it's x equals u plus z times your standard deviation.
Yeah. Because you do those first, so z times standard deviation.
Yeah. Okay. So then we already know that x is, we don't have x? Okay. X equals, let's put 1 for the mean for right now. The z-score is the bottom. Do we use the positive or the negative? Does it matter?
If you needed, click on the areas with the normal distribution curve so that the only shaded in blue is on the left side of the left line.
So then we should use the negative one.
Yeah.
Okay. So then the area, I'm going to say it's 0.35, and I'm going to multiply that by negative 0.385. Okay. Let's see if this does anything. So 0.35 times negative 0.385. So you get, then you add 1. So x equals 0.86525. And so it asks you, round your answer to 3 decimal places. So it'd be 0.865.
Okay, so do you think that number makes sense to you?
I think it does, because like as far as like calculating it, I feel like it was like it made sense, unless it doesn't make sense to you.
No, it makes sense. I'm just trying to figure out, the hard part about this one is it's not like a box plot. Not everything is like 25, 35, 75, 100.
Yeah.
So the number isn't always going to look exactly how it should in a uniform.
Yeah, I definitely agree. Okay, so then the next one is the 80th percentile.
80.
And what's interesting about this one is that because it's 80, it fills up to the next z-score. So I'm curious, I think we should use the positive one for this one. But I'm not sure. Because I feel like it would make sense. Like it wouldn't make sense to use the other z-score if it reached beyond it. You know what I mean? Because in the other one, it didn't go past.
It's
like,
going to be the same answer, though. Wouldn't it?
What? What part?
No, it wouldn't be the same answer. If you use the positive and the negative. For some reason, I thought it was squared.
Yeah, it wouldn't. I'm not sure.
But if you use the negative and you multiply by 1, you're still going to get a negative, so it'd be minus whatever the standard deviation is.
Yeah.
Yeah.
Oh, interesting. Okay, 0.8 times. So do you want to do the positive one or the negative one? Because to me, it makes sense to do the positive one because it reaches all the way to the positive one.
That line, it's at that line. So I would say, yeah, use the positive.
Yeah. Okay. So it's 0.6736 plus 1. And okay, so that's 1 point. But I also feel like
this is the only part where I'm like, it shouldn't be over 1.
Yeah. So maybe it should be the negative one then.
That's the hard part, because even though it's shaded to the left,
yeah,
it reaches that line.
Yeah. Yeah, I know. So you'd think, but
Mhm.
oh, shade to the left of each z-score, and you calculate. Okay, so the hint says, remember that to find the area between two values, shade to the left of each z-score, you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. Make sure your answer is positive. So even when we did use the negatives, it always turned out positive.
Mhm.
So I don't think we're going to have an issue with that. Yeah, and so it would be 0.3264. I feel better about this one than the one. Okay. So it'd be 0.326.
Okay, and then we need to go back up, and you said add.
I just wanted to look at 16 really quick because it says that like the hint that you should find the area but that you should shade to the left, and then that you should subtract the smaller area from the larger area. And I feel like we didn't do that, and so I want to do that because I'm just not sure about it.
Remember to find the area between two values, shade to the left of each z-score. And subtract the smaller area from the larger area.
Okay, so that would be but that's the thing, what small area are they talking about? Because I get the like, oh no, I get it, area, because it's 0.2743.
Mm-hmm.
And then the other one is 0.7257. So you subtract those, and that would be your answer, do you think? Or are we finding the area for both of them? Because this is only the 0.6, and then also the 0.7, and then would you subtract the difference between both of those? Does that make sense?
That's what I think, yeah. When you get 0.6 and then 0.7, you subtract.
Yeah, like the areas between, because you have to like calculate the area with like the smaller and the larger portion, and then and okay, 0.2743 minus 0.7257.
But isn't that going to be a negative?
Yeah, but I think it's probably just 0.4514 normally. And then with this 7, 0.7, and so then you would calculate the area to the left, which is 0.2420, and also to the right, which is 0.7580. Subtract those. 0.7580 minus 0.2420. And so you'd get 0.516. And I think you should subtract that by the 0.4514. And that would be your answer. Because what is the probability that a randomly selected observation will lie between the two values? I don't know if what I just did is making everything more complicated or if it's exactly what we're supposed to be doing, you know? Because like how did we get 0.762 again? Because I feel
we used the mean that we found, or the proportion of population. We used the z-score that we found, and then didn't we put the z-scores in, and then whatever the area was, we selected that?
I don't remember.
So if you put in 0.714 for your negative 0.714, the area is 0.2376 if you select the left side, but if you select the middle, it won't let me select the middle. I guess maybe it's just 0.2376.
0.714.
Mm-hmm.
Oh, are you talking about?
So if you put in the z-score, because remember the z-score was the same for both of them?
Yes.
Or to the above, and you put in those two, the area is what you get.
Between.
Mm-hmm.
But the area between negative 0.714 and 0.714 is 0.5248.
I got 0.2376.
Oh, it's because you have the it's because of the negative.
Yeah.
Oh, it's because you clicked the left side and the, okay, I get it. That makes sense.
I can't click the middle. I can only click the left side. So, oh, there we go. If you do the middle and the left side, that's when you get the 0.7624.
Okay.
Yeah, that's what we had.
Yeah.
So let's see. If you want, we can try it with the answer that we have, and then I can see which ones are wrong.
Yeah, I think I'm overthinking it, honestly, because now that we talked about it again, it makes so much sense. So yeah, let's just go for it. I really hope this one turned out.
They were all right except for
no way
15, 16, 17, 18.
Oh.
Yeah, so the only ones we did wrong were like the harder questions.
Oh my gosh. Do you want to retake it?
Yes, but I want to work off of the questions first and maybe see if like.
Oh, okay, yeah.
All it.
And I'm gonna write the answers that we got that time. That way that as we go around again.
Good idea.
we don't put in the same answers and feel like we did something different.
I'm gonna open up the prep one more time.
Okay. 15.
I'm gonna try to open the answer key and maybe I really wish it was as simple as they gave us formulas like this is how you find the mean, this is how you find the population density.
Yeah, because like in Math 108, it's so nice because you just it's just easier.
I was like, I think I have too many things open. Let's see. Blah, blah, blah.
Okay, so those ones are wrong.
Oh, okay, stop it. Oh, don't fight. I think that's why she's doing like the meeting today because I think this is a harder lesson for people to get.
Yeah.
Let's see. What are we doing in this one? Converting a z-score to a probability? That's one of them, isn't it?
So you're doing the percentile, is that? Yes, it's probability. It's probability.
Yeah, so it's converting a z-score to a probability. It says you need to use the applet, but how do you use the applet? See, but most of the time you're given the population mean, and the last two you're not.
Exactly. So, like, how are you supposed to find the mean if it's not there?
Yeah, that's what I mean. Type the z-score to click on the areas on the curve only until the areas of the left the scores are shaded. Yeah, see, it doesn't actually tell you how to do it. It only gives you situations. Like, it only gives you stories, and I don't like that. I'd rather be, like, told how to do it.
Yeah, because, I mean, it's all... I mean, I get it. They want us to figure it out, but at the same time, like, you have a teacher for a reason. You know?
Yeah. A percentile is a number such as that a specified percentage of the data. Okay, first we need to find the z-score and correspond. So click on the area under the curve until only the areas left of the positive z-score are shaded blue. So we did that. Type the desired number or percentile in the box at the top of the graph. But it wants you to type it in as 3 numbers. So like zero, if it was 90%, it'd be 0.900.
Oh, you mean like on the top? Oh, like 90%. Yeah, that makes sense.
Yeah.
Did we fill it out right? Because I feel like with the percent, like for example, 0.35, it automatically fills in the zeros.
Yeah. See, but the problem is like when you put in 0.35%, like 0.350, I wonder if that changes the answer. 0.350.
No.
You want to shade the middle too. Oh shoot, I moved. I moved the lines. I forget you can do that. And then no, it doesn't change the answer.
I know. Like,
what the heck?
Oh, you know what I wonder? I wonder if I don't know.
And then you solve for x. So then it says original equation. Put the 3, let's see, I need to write this down. I can't think out loud about this one. Okay, so you put 0.385. 0.385 equals x minus u over O. Like the weird O.
Oh, the standard deviation. Yeah.
Yeah. So then it's the variable. Oh no. Okay. The variable minus the mean over the standard deviation.
Okay.
He's standing on my hand.
Oh, so precious.
All right, standard deviation. Okay. So we need the variable. And it looks like, what the heck? Yeah, see, but it doesn't give you the sample mean.
And it does on the other ones.
I know. That's why I'm having a hard time with this one, because it's like, if you have the sample mean, you have the equation to do it.
Yeah, it's just plug and chug. You just put them in there and you know what to do with them. But if you don't have the answers, like the right amount.
In here, it's not in here.
Yeah, I don't know.
It's not like, oh, if you don't have the mean, this is what you do.
Yeah, okay, so that makes sense. These make sense. Because when you draw the bell curve for the 68, 95, 99.7 rule, in order, like, for Math 108, the middle is the mean. And so I don't get, like, where are we supposed to pull the mean from if the mean is 0? What if the mean is 0?
Well, okay, what is the mean? The mean is the middle, right?
Mm-hmm. And so what in the middle? Would it be 0?
The middle of the applet is 0. So variable, what's the variable?
Okay, so for example.
Okay, off of me. Thank you. Okay. Are you looking at number 13? That's what I'm looking at.
Oh, I just started looking at that one, yeah.
Oh, wait. Wait a second. It gives you the population mean. If it carries it down, I think it does, right? Because it's giving you the same values. So the population mean is 0.65.
0.
It says the population mean protein requirement for adults is 0.65, and the standard deviation is 0.07.
Oh.
So what's the variable? The variable is what you're solving for. So it'd be 0.60 minus 0.5 divided by 0.07.
Yeah.
That would be 13. And then that is, where's my phone?
But that's exactly what we got. But it wasn't negative this time.
But you're solving for z. Because if you're doing this equation, you don't know z.
Oh, okay, okay.
So, yeah, so let's see. So and then you input the z-score, and then you get the area. And then you shade to the left.
Okay. Oh,
right?
Maybe.
Does that make sense? Okay,
It
so
makes sense. Let's try that. Okay, so I got 0.714 as an answer. I wonder what do you get? Because I just want to make sure that's right.
0.60 minus 0.65, -5 divided by.
Oh, I subtracted it wrong.
So I got negative 0.714. So if you input that into the z-score, negative 0.714, and then you shade to the left, the area is 0.237. So I think you said that in the first place. You were like, oh, maybe this is how you do it. And that's right. What proportion of the population have a protein requirement that is less than? Because if it's less than, you shade to the left.
Yeah.
So if you're finding that proportion, the area is 0.2376. That makes better sense.
Yeah, so it's probably 0.238.
Yes.
Okay. And that's for question 13.
Yes.
Okay. And then what do we just do? The same for the...
I have no idea what it is. Okay, what proportion of the population have a protein requirement that's more than 0.60? So then you shade to the right, right?
For the... Oh, for the... Because it's the same one. It's just more.
Why wouldn't it let me shade? Oh, there we go. Okay. It's 0.2376. It's the same.
Yeah. Maybe it is the same.
Yeah, it might just be the same. I don't know. Well, because if you shade to the right, you want to know what's more than the 0.60.
Wait. What if the more is not necessarily... Because it doesn't make sense. Because what if the more is more than the less? So, like, not only the right side, but also the area in between. Does that make sense? Or does that sound a little ridiculous?
For some reason, it won't let me click the middle. Why? I don't know.
Because if you click the... I'm clicking it, and it says that it's...
764. Well, shouldn't it equal 1, ultimately?
Yeah. But the thing is, if it's asking you for, like, the right of something or the left of something... I'm just curious because that all of that is more than the less than. Does this make sense?
Yeah.
Yeah. So I don't know if that's what you.
Okay, there we go. Okay, but if you do to the left, including the middle, it's 0.764. It's the same thing. So
it's probably. Or what if between is the... No, because it's asking for less than and more, not in between.
Yeah, so I'm thinking for the 13, it's 0.238.
Uh-huh.
And then if you do more and you include the middle, then it's 0.762.
Yeah, but I'm not sure if that's right because
I'm not sure either, but I swear to God.
I know, because it's like... Because that's more than the less than. And so that makes me kind of curious on if this is on the right track or I don't know.
I have no clue. Not a single one.
I don't think
Let's see if maybe it's in the lesson somewhere.
Okay, and then I think it's just this... I could be the same value as well.
Yeah, it could also be the same value.
Because it would make sense for it to be the same value if it all has to equal 1. Because if it's more, then it's 1. You know what I mean?
Well, even if it's 0.3 or if it's 0.238 and it's 0.762, it equals
1.
1, which is what you want.
Yeah. Or what if it's...
If you're not given the mean... Hold on. I thought I had it, and I don't.
Okay.
Plus number of standard deviations equals upper value. Thought that was the mean. I lied. Okay. So I feel like that's what it has to be.
You know what else I'm curious about? But actually, because what if, I feel like I'm thinking too hard on this.
I feel like that's what it has to be, though, because it has to combine to 1, doesn't it?
Yes, but what if the negative, because what if number 13 is the 0.7624?
Mm-hmm.
And then the other one is the 0.238. I don't know. I feel like I'm thinking way too hard on this one.
I think let's try it. We can try it both ways. And if it doesn't work, I mean, we're not really losing any points. You know what I mean?
Yeah, because if either of them are, yeah. Okay.
Yeah.
And then, okay, 15.
So it's 0.70. So instead, it's 0.70 minus 0.65 over 0.07.
I got 0.714.
0.07? Yeah. 0.714.
Yeah. So that's the same thing as the last one.
I know, but but remember we need to plug in the z-score and find the area.
Oh,
right?
Yes. Yeah. Okay. Yeah. I was like, wait, but this can't be it. Because it's not it. Okay.
0.714. What are we trying to find? Less than 70%?
Yes, less than 70.
So it needs to be shaded to the right. Get out of there. If you do to the left, the z-score changes. Negative 0.714. Okay. So then it's 0.2376. So it's the same thing.
Yeah, I wonder if it's supposed to be like this.
I think it might be. Because, I mean, we're doing the math correctly. It's variable minus mean over standard deviation equals z-score. You put the z-score and you get the area.
Yeah.
I mean, that makes sense to me.
It makes sense to me too. Maybe we just had the wrong variables the whole time.
Yeah. 15, 0.238.
And then from number 16.
If it's the same. Winston, there's no one there.
Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. To find the area between the values, shade to the left.
So do you use the z-scores you found? So like 0.238 minus 0.238?
No, because those are the areas.
That's right. Okay. Oh, wait, but the z-score for both of them was 0.74.
Yeah.
Remember that to find the area between two values, shade to the left. So then do we put in 0.714 and then shade to the left? Or is that what we did?
I think that's what we did.
Yeah, I think so. Oh, gosh.
I don't know anymore.
But this is what it tells you how to do. I mean, how we just answered those questions.
Yeah.
We answered it the way that it tells you how to do it in the lesson plan.
Huh. Interesting.
Finding the probability between two values. So you find the z-score. And then you subtract them. So you find the first z-score, you find the second z-score, and you subtract.
Yes.
Yes. So yeah, so you just subtract them both, and then the probability is that.
Okay.
So we found the first z-score, and that was 0.60 minus 0.65 over 0.07, which was I don't remember.
Isn't that 0. Wait, hold on.
Because it couldn't it be negative and then you just transfer it to a positive maybe? Because I'm pretty sure this one was a negative. 0.65, 0.07. Oh, no, not what I meant. Oh, gosh, I have to do it all over again. 0.60 minus 0.65 equals divided by 0.07 is 0.714.
Sure. Point. Yeah. And that's what we've been getting for the z-score.
Right. And then if you do 0.70, what if this is like a trick question? I feel like it's a trick question.
They've already tricked us enough times.
I know. And then it's positive and it's 0.714. So, ow. But we're finding it the correct way. I'm looking at the thing right now.
Yeah.
And it says, wait, so what do you do when you have a negative? Ooh, that's interesting. We now answer the question by finding the area under the normal density curve. Oh, so you put in the z-scores, and then you find the area to the left.
Okay.
And under the normal density curve, which is to find the area between z equals. Yeah, so I think you put in both of those numbers. Wait a second, but it's the same.
It is the same, yeah.
Right, but I think you shade it differently, maybe.
So you shade it to the left and in the middle?
Yeah, that's what it says. It says.
Oh, and that's how we got the answer that we did. That makes sense.
Yeah, and then it says to the left of z equals 1.22. Also the area under the normal density curve to the left. So do you do the left one and then you do the middle?
Like subtract the difference between the two, or?
Yeah.
Because if you were to subtract the difference, you would just get what you got in the original one if you were just shading the left side.
If you do the middle, is it different?
Yeah, so if the z-score, we're talking about the z-score negative 0.714.
Yeah.
Okay, so if you shade only the left side, it's 0.2376. And if you shade that
to 0.238, right?
Yes. And if you put that the left with the middle, then it would be 0.72762. So
it's our answers.
Yeah.
But this is the way that they do it in the example. And then they did, so Z1 is 0.60. So let's say Z1 is the negative 2376. And then if you do Z2, it's the 0.762. So basically what they did is Z2 minus Z1, because Z1 was a negative, which I don't think you're supposed to do that, but that's how they did it.
Well, we don't have negatives. Do we?
Didn't we have? Yeah, we had negative 0.2376, right? For Z1, which was 0.60.
Oh.
Because we shaded to the left.
Oh, okay. Yeah. Yeah.
Then it was negative, but it says to find the area between them, subtract the smaller area from the larger area. That's why they reverse them. So then it's 0.762 minus 0.2376, which is.
Oh.
Does that make sense?
Yeah. So then you would essentially be adding them.
Technically, yeah.
So it would be 1.
I got 0.52.
Oh, maybe I am.
So basically you do 0.762 minus 0.2376, because they had a negative in their example too, and they didn't make it a plus. I think the reason why is you're subtracting it.
Oh, you're just subtracting it. It's not like you're making it negative. You're just subtracting.
Wait a second. Area under the, hold on. Maybe I can show you what I'm looking at and that'll help you.
Yeah, I think so.
All right, let's see. The entire screen, sure, share. Okay, so right here is where it says like this is what I'm looking at. So you see how it says
Yeah.
Z1? Oh, you can, I didn't realize you could see that too. Okay, so Z1 equals X minus U over O. So that's the variable minus the mean over the standard deviation, which is what we did to find the Z-score. And then we found the Z-scores, we put in the area, and the area was the 0.238 and the 0.762.
Yeah.
And then with that one, you now question by finding the area under the normal density curve, to the left of Z equals 1.22. So to the left of Z was 0.2376, correct?
Yeah.
Okay, and then to the left of Z equals, which is 0.2061 to find the area. Because when you did the negative Z, apparently it got a positive. So to find the area between Z and Z, we subtract the smaller area from the large area. Does that make sense?
Oh, yeah. Yeah. Okay, that makes sense because you have the one side and the other one and you just subtract the two of them.
Yeah, right. So now I'm thinking that it's the, what number did I get? 0.554? 0.5244.
0.5. Yeah. I think you're right.
0.524 is what I think number 16 is.
0.524. I think you're right. That makes a lot of sense. And so then with number 17?
Yeah, I mean, I'm literally reading it from the lesson. So if I'm just applying it wrong, I don't know.
I hope not.
All right. Okay, so find the 35th percentile for the protein requirements for adults. So then if you do finding the percentile, is the number of data set that is greater than or equal to 25%. So we can find the values of percentiles for a normal distribution by using the applet to calculate the z-score. And then plugging that z-score into our z-score equation and solving for x.
Okay.
So when we did the when we did the 0.350, we got the 0.385. 0.385. And then basically you plug that into the score. Oh, you may not have the mean. Let's see. And you want both of the middle sections highlighted. So 0.350. Yeah, it's the same. So 0.385. And so then type the desired area. The z-score responding will be displayed at the bottom right box. For example, to find the z-score responding, so that 90% of the area is left. Okay, that makes sense. And so the z-score that corresponds with the 90th percentile normal distribution, how do we find the batting average? We know that z, how do they know that that the mean is 0.261? Because it says the mean right there. And it says, we know z equals 1282.
Oh, and then it gives you the mean value. What if?
Yeah, but how do we know the mean value?
What if the mean is the area?
This one?
Yeah, you know how like it's the 35th percentile? Or is that not? Is that something else?
Well, I just wanted it to be like, if you don't have a mean, this is how you find it.
Yeah.
Not what it says. Maybe if you can solve for the mean.
Maybe.
I don't know how, but maybe you can.
It just doesn't make any. What?
Did you know the mean was 0.65 from the original equation?
Wait. Oh, yeah. Doesn't it? Yes. Yes.
Okay, so 0.524 is equal to, what's the variable? Oh, wait, you solve for x. That's how you do it.
Yes.
X minus 0.65 over the population. What's that name? standard deviation.
Yeah.
So over 0.07.
Yeah.
Okay,
Equals.
so then for x.
And solving for x is the.
So equals negative 0.65 divided by 0.07.
Hold on. But don't we have the z-score, which is the negative or the 0.385?
Did I put the wrong? I might have put the wrong number in there because I put 0.524, which was the area we found, wasn't it?
Yeah.
Oh wait, the z-score for both of them was 0.714.
No, I know, but for the 35th percentile, when you put the 35 in on the area part, the z-score is 0.385.
Okay, so that's what it needs to be, 0.385?
Yeah, I think so.
Yeah, I think that's what it needs to be. So then it's x. Give me.
Okay, so.
Okay, so then you do. Oh gosh, I lost it. Okay, 0.65 negative divided by 0.07 equals x. I got negative 9.28.
Okay, I have not gotten there yet. I'm almost there. Plus 0.65. I got something really different.
I could have done the math wrong because I'm trying to do a negative on my like phone calculator. So negative divided by 0.07. I still got negative 9.28.
Because I got 0.67695. Because what I did is I did the z-score, but instead I didn't have a value for x. So it was the z-score, which is 0.385 equals x minus 0.65 over 0.07. And so in order to get the 0.7 out of here, you multiply it so that they cancel out, and then you multiply those two, and then you would add the 0.65.
See, that makes more sense than what I'm trying to do. So, okay. So then you got x equals what?
0.677 rounding.
That makes sense.
Okay. And so that would be the answer for number 17, right?
Let's see. Oh, you're supposed to multiply both sides by the standard deviation. Isn't that what you did?
Yes.
Okay, and then that cancels
the standard deviation out.
Oh goodness, I've forgotten normal principles of math. Okay, yeah, so when you solve for x, that's how you find it. So x was the 0.677?
Yeah.
Okay, yeah, so that's going to be 17.
Oh, cool. And then 18 is just basically the same thing, right? But with the 80th percentile.
Yep, so do the same thing, 80th.
0.8. The z-score is 842. So then you would... So the z-score is 0.842 equals x minus 0.65 over 0.07, right? Because the standard deviation would be the same.
Yep, and then you multiply each side by 0.07.
And
then...
So, and then you add 0.65.
Yeah. And then x equals
0.709.
That makes a lot better sense.
Yeah. 709. Okay. I feel pretty good with the answers that we got because we like looked it up and again and stuff like that. So, unless you have any questions right now.
No.
Okay. Do you want to retake it then?
Yeah, let's
Okay.
retake it.
I hope we get these right.
I know, I was going to say, I hope that they're all right.
I know. Group meeting quiz. Okay. Worst comes to worst is that we get a 70%, which is better than last week.
Right. Oh, wait, no, I did actually group meeting. What was number 3?
Number 3 was
Not 1.
1. Yes. And then 4 was
False.
false. 5.
And then 5 is true.
And then number 6 is C.
And then
7 is B.
8.
8 is 68. 9 is 0.683. 10, 0.955. And 11 is 0.997. And then 12 is the values match the rule.
Okay, so then 13 was 0.238. 14 was 0.762.
Okay. 15 is 0.238 as well, right?
Mm-hmm. And then 16 was 0.524.
Okay, and then 17 is 0.677.
And then 18 was 0.709. 0.709.
Okay.
All right, let's see.
I really hope we got this one right.
I know, me too.
We got
almost right.
Oh my, yeah, good job. Oh my gosh. Okay, only question 17.
Yeah. It's number 15, which is weird because we use the exact same way to get it. So unless like our rounding was off, which who knows anymore.
Yeah, I don't know. I'm gonna screenshot these and I'm gonna send them to the tutor, or I'll go to the math lab because I'm at BYUI, so I can go to the math lab whenever.
That's so weird though, because when we did number 18, we did the exact same way to find it as number 17. So
yeah, I don't know.
Oh well, I'm happy with the 90.
I am so happy right now. We're killing it. This was successful.
Figured it.
Yeah. Okay, cool.
It only took 2 weeks, but we figured it
right? Cool. All right. Yeah. Well, I'll see.
Did you want to do a quiz or no, you have plans?
Oh, the homework quiz? Did we have a homework quiz?
Yep.
What?
Yep.
No, don't tell me we have a homework quiz.
We do.
Safari is not working. What the heck?
I have to do it on Google Chrome because mine doesn't work on Safari. Questions.
Oh, really? Then yeah, let's just do it. It's fine. I don't care.
Well, now we know how to do it. So
yeah.
Faster. The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal with a mean of 70, standard deviation of 10. Using this, what percentage of students will complete the exam in under 50 minutes?
Oh, yeah.
We can find the Z-score. And go.
Start quiz, okay. Okay. So,
okay, give me 1 second. I have to go grab another pen.
Yeah. Okay.
Oh my gosh, I was sitting on it the entire time. Okay. There we go. All right, so to find the z-score, you need variable minus standard deviation. So 55 is the variable, or 50 is the variable, minus the mean 70 over
60,
10.
50. Okay, so the 50, so it's 34, 13.5, 2.35. Okay, so with this one, what percentage of the students will complete the exam in under 50 minutes? So you want to know the below, and then
you get, let's see, negative 20 divided by 2. So you should have gotten like 2 or negative 2.
Hold on, I have a thing I want to look for. So I don't remember all this stuff out.
2. And then you put in negative 2. And you get area of 0.0228.
Okay, so I think, I'm just trying to remember.
So it's 2%.
Because the 50, it would be...
Isn't 50 the variable? That's what I put in.
So I'm doing it a different way. Because that's how I know how to do this rule. Where you draw it out, and then you put the... So like the standard deviation is like 10. So it's the difference between each of them. And then you just add them. But I'm trying to figure out the last one because it would be 99.7 minus 100.
Give your answer as a
No.
When I did it on the applet.
What did you get?
2%.
So it would be 0.2.
Yeah, but it says give your answer as a percentage. Because it's 0.02. It's 2%.
Oh, okay. Then yeah, 2%.
Yeah, that's what I got, but I don't know if that's right.
It either sounds, I think it sounds about right.
Well, because I did the z-score formula, and I did the variable, which was 50, minus the mean, which was 70, over 10. So I got negative 20 over 10, and then that's negative 2. So z-score of negative 2.
Oh, okay.
Yeah, and then I put in the applet, the negative 2 and 2, and that's when I got 0.0228. So 0.2.
Okay.
Does that make sense?
0.2 would be 20%.
0.02.
Oh,
0.
okay.
Mm-hmm.
Okay, yeah. Then yeah. Okay.
Yeah, so but I'm trying to make sure that that makes sense. Because then the answer would just be 2. And there.
Yeah.
Oh, the next one should be easy. Because then it's just the variable is 3.144 minus the mean of 2.397 over 0.612. I got 1.22 for the z-score.
1.22.
Mm-hmm.
Okay. Yeah, that makes sense.
Okay. Let's put that
There was
down.
no more variables after that?
Well, because the mean is 2.397, the standard deviation is 0.612, and then the observed value is 3.144. So if you do all of that, you get 1.2205.
Oh, okay, yeah. No, but if you round it, wouldn't it be 1.2? 2, 1? Because the 5 makes the 0, 1.
That's a good question. I'm not sure.
I think so. Because it's asking you to answer accurate to 3 decimal places. For example, 4.567. I feel like that makes sense.
2.3? No, 1.221.
Yeah. Okay. Height of 5th grade boys is normally distributed with a mean of 57 and a standard deviation of 2. What is the probability that a randomly selected 5th grade boy will be between 53 and 61?
So you have to find the, oh, okay. See, we did this one before. So it's 53 minus 57
Oh,
over 2 equals a z-square. And then you plug in the z-scores, find the area, and subtract the area, right?
yes.
Okay. So 53 minus 57 is -4 over 2.
Which is negative 2.
Yeah. Which is what I already have in. So it's an area of 0.0228. 0.0228 minus.
And then it's the 61 minus 57. 2.
Where did I do that? Okay. 57 over 2, which is 4 over 2. So it's positive 2.
So it'd be.
It'd be 0.
So it would just be 0.023 approximately. But it's none of the. Oh, wait.
It's 0. It zeroes it out.
Wait a second. Because if it's the standard deviation.
Yeah.
And if that's what we're talking about. Okay, so this is 68.
Well, you have the standard deviation. They're asking for the probability. So
yeah.
53 and 61. So we found 53. 53 was negative 0.228. So, and then it's minus 0.228. So do you add them?
Hold on. I remembered this and I wrote this down. And I don't remember where. But somewhere fairly recently.
Because if you add them, then you get more near approximately 0.68.
Yeah. Okay. 2.35. And then, because I don't know. The way that I do the rule is different. So I don't know. Because if the mean, and so the standard deviation is 2. So then it's 57 plus 2. So
yeah,
it's
see,
59.
For me to be, because you get negative 0.0228 minus 0.228 when you add them.
Hold on. Minus 2 is 53. And so you're looking in between 53 and 61.
Oh,
that's 95.
Highlight. Yeah, you have to highlight the middle. That's right.
Yeah.
That's why it's different.
Yeah, because the way that I did it is I just did the standard deviation and I just filled it out.
Yeah. Okay, that makes sense. Yeah, because I forgot you have to highlight the middle portion.
Yeah.
Human so it's approximately 0.95.
Yeah. Human blood pressure levels are normally distributed. If you measure an individual's blood pressure and found the blood pressure level to have a z-score of 2.1, what would you conclude about that person? So if it's
anything beyond 2 or negative 2 would be considered unusual or extreme.
So it would be
blood pressure is unusually high compared to others.
I think so. Did you just plug it in?
No, that was a rule. So it says anything beyond for extreme or unusual values.
Oh.
Yeah, for a z-score, it says anything beyond 2 or negative 2 would be considered unusual or extreme.
Yeah, then it's definitely that one.
Yeah, because it's numbers that are outside of the bell curve are extreme. So plug in 2.1.
But yeah, if that's a rule, then that's probably what I
It's
mean.
outside of the bell curve anyways.
Yeah. Okay, what does this graph tell us? The data is not normal. That's for sure.
Mm-mm.
It was definitely chosen randomly. I would say the data are not approximately normal.
Yeah, that sounds right, because it's not going to make a bell.
Yeah. Scores on the MCAT exam are normally distributed with a mean. Which two values will 95% of MCAT scores fall? So if you have a mean of
A mean of 25.
and a standard deviation of 6.4. So 25 plus 6.4.
Oh, and you have to do the z-score. The z-score of 95.
Is that what it is?
Well, you have to do the z-score.
Oh, okay.
1.645, because remember, then you put it on the other side of x.
Yes.
Yeah,
Wait,
and then you solve. So it's because you don't know x, you don't know the value.
oh, yeah. So then it would be between
25 over 6.4. You multiply by 6.4 on both sides to get rid of that one.
It's the second one.
The 12.2 and 37.8.
Yeah.
That makes sense.
Scores on the LSAT are approximately normal with a mean of 150.7 and a standard deviation of 10.2.
So 157
So
minus 150.7 over 10.2.
yeah, because yeah.
Yeah. And then you find the z-score, and then it wants round to 3 decimal places. It's like all over the board. 157 minus 150.7 equals divided by 10.2. 0.617 is what I got.
Yeah.
But when 0.618, because the next number is a 6. 0.618.
Yes. Yeah.
0.618.
Yep.
Save.
Oh, so now they're asking above.
What is the score? Okay, so now do you plug in the 0.618, or do you have to do, it'll be about the same. So 0.618, and then you do shade to the right.
I think so.
So
0.2683. So 0.268.
do you need to shade the middle?
I don't think so.
Yeah, because it's not equal to and above. I think it's just the right one. So 0.8.
And then complete this sentence. About 68% of LSAT scores will be in between 18 and 30. This is these are different values.
Well, do you have the mean?
Yeah. Mean? So the mean is
it has to be within one standard deviation of the mean.
Yes. So 150.7 subtracted by 10.2. So that's 140.5. It's the 140.51.
There we go. Number 3. Yeah.
My
35th percentile of the LSAT scores.
Okay.
One decimal place. Use the applet. Okay, so it's
0.35.
Didn't we just do that?
I feel like we did. I feel like this one.
Give it accurate. Oh, but the values are different. So
Yeah.
the z-score, it's 0.385 equals x minus whatever that number was. Minus the mean of 150.47.
Yeah. Divided by the standard deviation, which is 10.2.
We multiply again by 10.2 on both sides. Solve for x. Oh yeah, high number.
3.927 plus. Yeah, so x would be 154.6.
Can you have a mean that high or a z-score that high?
I think you can, depending on the values.
The example is 124.7. Yeah, so I think you're okay.
Yeah. 154.6.
Let's see how we did.
Hopefully good.
Right.
That's all I ever hope.
Which is so weird because we use the exact same formula to do it.
Ugh, so annoying.
I know. Wait, number 1 was incorrect, but how? And then how was the last one incorrect?
I'm not sure.
Yeah, we used the applet. We used the proper.
Oh, I think question 1 was wrong because we were supposed to fill out the because in under 50 minutes. So on the this is really messy, but like in between there are values, and so like the 34 and the 34 equal 68, and then this part and this equal the 95, and then this and this equal the 99.7, and then right here is helps it equal 100. And I was looking for this, and I think what you would have done is the 50 was about here, so you would have added those two values.
Okay.
You know what I'm saying?
Yeah, but what about for the last one? The last one doesn't make sense.
Yeah, I don't know about the last one at all. Like, I don't know how this happened.
Negative times. Wait, no, it's divided. 150 points. Oh no, it is multiplied. Times 10.2 is 1,000. Oh wait, but the other one's going to be a 1,000 too. 35, 0.385 times 10.2, 3.92. And then we get 150.7 negative times 10.2 is negative 1,537.14. 1,537.14. So if you add that to both sides, I have no idea.
I don't know. I'm gonna ask someone in the math lab.
Yeah, serious, I don't know, because we used the exact same formula for 68 as we did for 35.
So, yeah, and we got the other one right, so.
I don't know. All right, I guess I'll ask the tutor hopefully tomorrow, and I'll be like, hey, I don't understand.
Yeah.
I mean, 70 is good. I'm happy with the 70.
I am too. Okay.
All right.
All right.
Well, I'm posted. I will see you on Tuesday.
Okay, see ya.